Welcome to the third film in this series about winter road forecasting. In this final film, we'll look at the differences that can occur between winter forecasts, and also we'll look at the factors that make a big difference on the type of weather we see at the surface. The Met Office is responsible for providing up-to-date weather information and tailored warnings for many different users. Because the forecasts we provide are designed to fit the varying requirements of the end users, they can sometimes seem to differ, which can cause confusion. Here is an example to explain why this is. TV broadcasts are designed for and aimed at a wide audience and cover a large area, usually a region of the UK or indeed the UK as a whole. These forecasts also describe the weather for these areas up to 5 days into the future in a very short time. Therefore, a generalised approach has to be used. In contrast, site-specific or road forecasts are produced for a relatively small area so that local effects can be taken into account. For example, whether the site is on a hill or a valley. This could mean the site in question could get cooler or warmer temperatures than those stated in the TV broadcast. The more detailed view provides the user with a more accurate forecast for the particular locations of interest. This difference between forecasts for the same area over the same time period is what sometimes causes confusion. An example of a particular weather situation that causes this confusion is falling snow and the resulting accumulation amounts. Any threat of snowfall in the UK usually hits the headlines. However, falling snow does not necessarily mean snow will accumulate or even reach the surface. Snow can evaporate as it falls, turn to rain, or melt as soon as it hits the surface, meaning its impact can be minimal. The confusion arises when snow is forecast to accumulate. Snow depths mentioned on TV broadcasts and the national severe weather warnings are based on a grass surface where snow is more likely to settle than on roads, so snow depths will appear to be greater than those produced on any road forecasts. Therefore, snow accumulation forecasts can often look underestimated when compared to the TV broadcasts and national severe weather warnings. Dealing with falling snow when it settles is a tough task. It is generally thought that salt is the solution for wintry conditions. However, this is not necessarily so. In order for salt to be effective against snow and ice, there needs to be some water present to form a solution, as previously discussed in video 1. With a freezing rain scenario, the rain freezes instantly on impact, forming a layer over the salt, rendering it ineffective. Snow can also form a layer over the salt without melting if it is dry and powdery. In these situations, other methods of snow or ice clearance are needed. These include chemicals or manual labour. In the final part of this film, we will look at depth temperatures and the time of the season effect. Something that can have a great influence on the type of weather we see at the surface during the colder months is the depth temperature. Its effects are mostly noticeable at the beginning of the winter season. The depth temperature is the measurement of the ground temperature at around 30 centimeters below the surface. The temperature of the ground changes fairly gradually during the winter season. However, the impacts of a particular weather scenario at the beginning of the season compared to the same weather scenario later in the season can be dramatically different. At the beginning of the season, the depth temperature has had the long days of spring and summer to soak up heat. This heat is retained below the surface during late autumn and early winter, even when the temperature above the surface is a lot colder. This means that even though conditions could be cold enough to give frost or ice, the heat from below radiates up and can keep the surface temperature above freezing, thereby stopping any frost or ice forming. As the season goes on, the days become shorter and the nights longer, so the depth temperature cools, meaning it has less and less of an effect, and towards the end of the season, it actually has the opposite effect. During early spring, surface temperatures may be warm enough so that it is reasonable not to expect any frost or ice. However, the temperature at depth sucks the warmth out of the surface, allowing temperatures to fall, which could then allow frost or ice to form unexpectedly and can also affect how readily snow settles. A final factor is the angle of the sun. During midwinter, the sun is very low in the sky, so the effect it has on any lying snow is minimal. By springtime, the angle of the sun is much higher, allowing more energy to be absorbed by the lying snow, causing it to melt more quickly. In this film, we've looked at some of the differences that can occur between the various forecasts. Hopefully, this series will have provided you with an insight as to some of the forecasting techniques we employ here at the Met Office. Thanks for watching. If you'd like to find out more about the weather and the science behind our forecasts, please let us know by emailing openroad@metoffice.gov.uk.